Okay, a farmer has 160 feet of fencing to enclose 2 adjacent rectangular pins. So 2 adjacent rectangular pins basically means they share one of the sides. So I'm going to call all 3 of these sides X. They're all going to have the same length, and then all the way across is going to be Y. Alright. Now you could separate that into Y, 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 but that would just make you have to do each pin separately. It's better if we can do it as one giant pin. So let's start with the area. The area is going to be X times Y. Alright, just length times width, or length times width, however you want to look at it. That's the total area. The amount of fencing is going to be X plus X plus X, and Y plus Y. And the amount of fencing we have is 160 feet. Alright, and we are trying to maximize the area. So I need to find the derivative of the area, but before I can do that, I need to rewrite it in terms of one variable. So let's solve this thing for, let's solve for Y. So 160 minus 3x over 2. Alright, so that's going to be 80 minus 3 over 2x. Okay, I'm going to take this and we're going to plug that in for Y. Wonderful. Let's see, what is my restrictions? Well, we're talking X is the length, so clearly X has to be greater than 0, between 0, and then we only have 160 feet of fencing, so the most I could possibly use is 160. But again, I know that this is an upside down parabola, so I know that the maximum is going to be whatever the critical point is and not the endpoints. So that saves me some time. Alright, A prime right, set that equal to 0, subtract 80, divide by 3, 80 over 3. But I need the Y value as well, so let's see, Y was 80 minus 3 halves. Alright, my Y value ends up being 40. So, my dimensions are 80 over 3 feet, or you can write that as a decimal, and 40 feet. And in case they wanted to know what the maximum area was, the maximum area is 1066.667 feet.